This lesson is on placing rational numbers on a number line. Rational numbers include positive numbers and negative numbers. They also include positive and negative fractions, positive and negative decimal numbers. So let's take a look at problem number 1. Negative 1 1/3, negative 12/5. Now, what they're wanting us to do is to find out which one of these numbers is greater. Well, we can use this number line, and we find negative 1 1/3, and it is right here. And then we find negative 12/5, and it is right here. And remember, greatest is to the right, and least is to the left. So this is going to be greater than this. So negative 1 1/3 is greater than negative 12 . Now notice how they're written in reverse order, so don't be confused and come down here and write this facing the wrong way. Make sure that the greater end, the larger end, is facing the larger number. And negative 1 1/3 is larger or greater than negative 12/5 because it is to the right on the number line. Now the question is, what would we do if we didn't have a number line? Let's take a look at this. Well, we have an improper fraction and we have a mixed number. What can we do? Let's convert this to an improper fraction. 1 times 3 is 3, and 3 plus 1 is 4. So this becomes 4/3. Well, we still have a problem because we have a 3 as a denominator and we have a 5 as a denominator. So we have to find common denominators. That means a number that goes into both. And we can find that on the ladder, 3 and 5. The only number that goes into 3 and 5 is 1. 1 times 3 divided by 1 is 3. 5 divided by 1 is 5. And we can multiply down the L because we need the least common multiple, the LCM. So we need to have the least common multiple, or LCM. We find that by multiplying down the L. 1 times 3 is 3, and 3 times 5 is 15. So the least common multiple is 15. LCM is 15. So now we need to convert 4/3 and 12/5 into fractions over 15. So I'm going to write 4/3 up here so we'll remember it. 4/3. So 4/3 and 12/5. And we need to multiply them by something to turn them into fractions over 15. So we use a magic 1. Well, 3 times 5 is 15, so I have to put a 5 there. And 4 times 5 is 20. And 5 times 3 is 15, so I have to use a 3 here. And 12 times 3 is 36. So now I have 20/15 and 36/15, and that means this number right here is greater than this number. But we have to think about something. One of these is positive and one of them is negative. So let's write them over here, and I'll write them in red so we can see it a little clearer. We have 20/15, and we have 36/15, and they're both negative. Well, if they're negative, that means this 20/15 is going to be right here on the number line, and 36/15 is going to be further that way, because remember, with negatives, going from 0, it's going to be going 1, 2, 3. So if this is 20 here, then 36 must be further down the road here. And actually, it's right here. So this number right here is closer to 0 or further to the right, than this number, so this is our greatest number. Now let's look at problem number 2, 11/8 and 1 and 88/100. Let's locate them on the number line. We have 88/1 and 88/100, and we have 11/8. This one is further to the right. That means 1 and 88/100 must be greater than 11/8. What if we didn't have a number line? How would we do this? Well, what we should do is convert them either into fractions or mixed numbers or decimals. Let's go ahead and convert this one into decimals. Since this is 1 and 88/100, we have 11/8, or since we know that all fractions are also decimals, we can do 11 divided by 8. And 8 goes into 11 one time. 1 times 8 is 8. And 11 minus 8 is 3. So we need to have our decimal. Place the decimal here and here. Bring down another 0. 8 goes into 30 3 times, because 3 times 8 is 24. 30 minus 24 is 6. Bring down another 0. 8 goes into 60. Well, 6 times 8 is 54. And 60 minus 54 is going to be 6. Bring down another 0. 8 goes into 60. 6 times again. 6 times 8 is 48. 60 minus 48 is 2. Bring down another 0. 8 goes into 20 2 times. 2 times 8 is 16. And 20 minus 16 is 4. Bring down another 0. And 8 goes into 40 5 times. So we have 1 and 0.36625 paired with 1 and 88/100. And it looks like, wow, that is so much bigger than that. Well, let's think about this. What numbers go, if we have the same number of digits in our decimal fraction, we need to have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's do that like that. Now we have 5 digits here, 5 digits here. And even though these 3 are zeros, this becomes 88,000. And this becomes 36,625. That means this one right here is larger than this one. Don't be confused, especially with decimals. You have to have the same number of digits to compare them. And if you look here, the largest number is always here. So the ones are the same. And then this 3 is smaller than this 8. That right there tells you that this number is the greatest number right here, because when you compare these two numbers, this is greater than this. You're not looking down here, you got to look up here. So even though this had longer digits than this, it was not greater. For our last problem, we have 66/100, -1/3, and -5/12. And we need to put these in order from least to greatest. Well, this is a positive number, 66/100, and these two are negative numbers. So I know this is going to be my greatest number. So I'm going to go ahead and write that over here as 0 and 66/100. By the way, I know that this 6 is a repeating decimal here. That's why there's that line above it. And I also know that 66/100 is actually it's a repeating decimal called 2/3. Just one of those things that you know, just like 33/100 is a repeating decimal that written as a fraction would be 1/3. So let's just, now that we've taken care of that, we can just concentrate on these two negative numbers as to which one is the greatest number. So we have -1/3 and -5/12. For right now, we'll ignore the negative sign and we'll just take a look at the fractions themselves. We have 1/3 and we have 5/12. And we need to find a common denominator. Well, I happen to know that 3 can go into 12, but just to be safe, I'm going to find the LCM, the least common multiple. The least common multiple of 3 and 12, and the way I can find that is to place them on the ladder, 3 and 12. Now, there's only one number that goes in here besides 1, and that's 3. So we start with the lowest prime, and we look at 2. Does 2 go into 3? No, not without a remainder, so I can't use 2. The next lowest prime is 3, and 3 goes into 3 one time, and it goes into 12 4 times. And the way I find my least common multiple from our rules of the ladder is I multiply down the L. 3 times 1 is 3, so 3 times 1 is 3, and 3 times 4 is 12. So my least common multiple is 12. So I need to turn both of these into fractions over 12. Well, here we go. I can multiply this by a magic 1 of 4 over 4. 3 times 4 is 12. 1 times 4 is 4. So 4/12 is my fraction for this right here. So I'll write negative 4/12. And then I have 5/12, and I need to turn that into something over 12. Well, that's pretty simple because 5 times 1 is, 12 times 1 is 12. So 5 times 1 is 5. Notice that 5/12 times 1 is 5/12. So this can stay negative 5/12. And, now it would be really tempting for me to say that negative 5/12 is larger than negative 4/12. It would be really tempting because 5 is bigger than 4. But remember, these are negative numbers. If I have a number line and I have 0 here and I start writing negative 1/12, well, negative 4/12 is going to be in this direction. And then the number right after negative 4/12 is going to be negative 5/12. And since to the left is lesser, to the right is greater, this has to be greater, negative 4/12 has to be greater than negative 5/12. So my lowest number in this series is negative 5/12. After that is negative 4/12. And after that is 66/100 or 2/3. And 2/3, I can convert that into a fraction. 2/3, I can convert that into 12. 3 times 4 is 12. So my magic 1 is 4 over 4. 2 times 4 is 8. So I can say this here is 8/12. So I have negative 5/12, negative 4/12, and negative 8/12 from least all the way to the greatest.